I would like to review the solutions of the Prereq for linear inequalities. The first skill is to graph the solution set of a linear inequality. We have x is greater than 5, so this represents all values that are larger than 5. We place 5 on the number line and then shade the portion of the number line that corresponds to those solutions, which would be to the right of 5. We put an arrow to indicate it extends infinitely. But notice that 5 is not greater than 5, so we indicate that we exclude 5 by placing a parenthesis on 5. X is less than or equal to 2. We place 2 on the number line. Shade the portion that is less than 2, which is to the left. But we are also permitted to be equal to 2. So since 2 is less than or equal to itself, we indicate that we can include 2 with a bracket. So parentheses excludes, bracket includes. I like to think of the bracket like as having an equal sign, right? Because of the way it's squared off there, think of that as equal. So if your inequality has an equal part, we're going to put a bracket there. X is less than -1. We place a -1 on the number line. Less than -1 is to the left. We cannot equal -1, so we exclude that with a parenthesis. X is greater than or equal to -3/2. We put -3/2 on the number line. Greater than is everything to the right. And we are permitted to equal -3/2, so we place a bracket on the -3/2. Skill 2 is to write these intervals. Skill 2 is to write each graph in interval notation. To write a graph in interval notation, we want to read the graph from left to right and place the smallest and largest number represented in those set of numbers in this interval. So think about from 5 to infinity, we don't start until the value 5, but we're not including 5, so we keep a parenthesis there. But the graph doesn't stop. In fact, it never stops, and so we represent that by writing positive infinity and put a parenthesis there because we can't ever reach infinity. In the second graph, we start at the left, right? We're starting all the way down to the left of the number line, which is something we can't reach, that's negative infinity. But where does our graph stop? Well, it stops at this 2. And we can include it, so we put the bracket. Number 7 is everything to the left of -1, so again, we're starting from the left at negative infinity. And where does our graph stop? It stops at -1, but not including -1, so we put a parenthesis. In number 4, the graph begins at -3/2 with a bracket. So we place a bracket in the interval, but we don't stop, so we represent that with positive infinity. So think about the interval as representing where is the graph lit up or turned on, right? What part of the number line has the point shaded, but always writing from left to right. Now, in skill 3, we're going to apply the addition and multiplication properties of inequality to solve inequalities. The only difference between this set of problems and equations is that when you multiply or divide by a negative number, you have to reverse the inequality sign. X plus 7 is greater than 19. We're going to subtract 7 to get x is greater than 12. To graph it, we place 12 on the number line, numbers greater than 12 or numbers to the right, and we can't include 12, so we put a parenthesis on it. The interval is from left to right, so from 12 to infinity, both having parentheses. Negative 6x is greater than or equal to 36. To solve for x, we have to divide each side by negative 6. The dividing by negative reverses the inequality symbol, so we get x is less than or equal to negative 6. Graphing this, we place negative 6 on the number line. Less than 6 is to the left, but we can equal negative 6, so we put a bracket at negative 6. The interval is from negative infinity to where it stops to the right, which is at negative 6. Negative 5 is less than or equal to x minus 6. To isolate the variable, we add 6 to each side. Negative 5 plus 6 is 1 is less than or equal to x. This inequality is written reverse of what we normally see with the variable on the left. We can switch the sides of an inequality, but we have to switch the symbol as well. If 1 is less than or equal to x, that means that x is greater than or equal to 1. So on a number line, we place the 1 and then shade everything larger than 1. And we are enabled to equal the 1, so we can have a bracket there to get bracket 1 to infinity for our interval. 2/5 p is less than 12, so we divide by 2/5. That's dividing by positive numbers, so the inequality symbol stays the same. But to divide by 2/5 is the same as multiplying by the reciprocal, which is 5/2. So therefore we get p is less than 2 goes into 12 6 times, and 6 times 5 is 30. So on a number line, we place the 30 and shade less than 30, which is to the left of 30. And we're not permitted to equal 30, so we put a parenthesis. So that's negative infinity to 30 with parentheses. And that's the solution to these pre-check problems. So if you have any questions, don't hesitate to contact me. Thanks.